This is our second video in the Conics unit, and it goes over ellipses. As you can see on the left-hand side of the screen, there's quite a bit of information. I do recommend that you copy this down in your notebook or take a screenshot and print it out and paste it into your notebook because you will need this information when trying to solve problems. Right off the bat, you'll notice two standard form equations for ellipses. The difference between them only has to do with the way that the ellipse is oriented. So ellipses have a major axis and a minor axis. So basically what that means is the ellipse is either laying horizontally or it's standing vertically. So if we look at this picture right here, we know that the major axis is horizontal because that's the longer side of the ellipse. And if we look at this picture right here, we know that the major axis is vertical because here the longer side of the ellipse is standing straight up. So if you pay attention to the two standard forms of the equation, the only difference is between the location of this letter A and this letter B. So A and B are important because they represent a specific distance. A represents half the distance between our vertices, and B represents half the distance between our covertices. So as you pay attention to your standard form equation, you need to look at both of your denominators, and whichever denominator is larger, that is going to be your A. So if your A is located under the X, then you know that you're laying in the horizontal direction. Whereas if your A is located under Y, you know that you're standing in the vertical direction. There's tons of other information on this chart. For instance, you know that H and K give you your center, but this is something that we already know from our circles unit. You can also find the foci, which are points that are located right in front of the vertices. You can find your covertices, you can find your major and minor axis, and you can also find a third variable, which is the letter C, which is half the distance between the foci, which is right here. So basically this chart tells you how to look for various points using your standard form equation. Now, we're focusing primarily on writing a standard form equation. So the most important thing is when you're writing an equation, you need 4 pieces of information. You need A, you need B, you need H, and you need K. So here we're going to work backwards for a minute. In the right-hand side of your screen, I gave you a standard form equation of ellipse. So what we're going to do is we're going to pull the 4 most important variables out of that equation. So let's start with A. We know that A is always going to be the larger denominator. So if I look right here, 36 is bigger than 9. So I know that this is my A. Also, because A is located under X, we know that this is going to be a horizontal ellipse, okay? So A is always going to be the square root of whatever's in our denominator. So I'm going to take the square root of 36, which means A is 6. Now moving on to B, which as default we know is simply just 9. Square root of 9 is 3. H is always located with X, same thing we saw in circles. So here, our H is going to be 3. And then our K is always located with our Y variable. And remember, the standard form equation is always Y minus and X minus. So if we look right here, X minus, Y minus, X minus, Y minus. So since I have a positive sign here, I know that this had to have been Y minus -1. So K is going to be -1. So if we also take a look at our chart, there's one more variable, the letter C, and we can find that using the information we've collected because we know that there's a relationship between C, A, and B, where C is equal to the square root of A squared minus B squared. So let's go ahead and do that. C equals the square root of 36, because that's what A squared is, minus 9. which gives us c is equal to the square root of 25, which we know is simply just 5. So now that we know what A, B, C, and H and K are, we can take a look at this chart and we can find other information about our ellipse. For instance, I know my center is located at HK, which means the center of this ellipse is at 3, -1. I also know that my foci are located at H plus minus C, K. What that means is I would take H and I would add C to it, but then I would also take H and I would subtract C from it. Because remember, the foci, there's 2 of them, so it's always plus minus. Same thing with my vertices, H plus minus A. Same thing with my co-vertices, H, K plus minus B. There's always 2 points, so these 3 right here are always going to be plus minus. I also know my major axis is located at y equals -1. I know my minor axis is located at x equals 3. So now, using all the information that we just learned in the previous slide, we have to be able to write the standard form equation of an ellipse using characteristics of our ellipse. So we know for this particular ellipse that it has vertices located at -6 and 0, and it has co-vertices located at 0, 5, and 0, -5. So the important thing to identify here is if I know where my vertices are located, I can get A. And if I know where my co-vertices are located, I can get B. And on top of that, using the midpoint formula, I can find the center of my ellipse as well, which would give me H and K. So I'm going to start by finding the distance between my vertices, which is going to give me twice A, because remember A is only half the distance between my vertices. So what I'm going to do is I'm going to modify the equation that we use to find distance by simply just dividing it by 2, or in this case, multiplying it by 1/2. In an effort to save time, I'm going to just completely go through the work for distance for vertices and co-vertices. It's very much the same as what we did in the circles video, but if I were you, I would pause right now and try doing the work on your own and then checking to see if you did it correctly. Okay, so here I just plugged in x1 and x2 and y1 and y2 of my vertices so that I could find A. Then I followed the equation, which gave me that A equals 6. Quick reminder, it doesn't matter which point you make point number 1 and which point you make point number 2, because you're always going to end up squaring the difference of the 2 numbers, so you'll end up with the same answer. Then I took my co-vertices, plugged them in, x1, x2, y1, y2, followed the equation, and I got B equals 5. Now to find our center, we have to use the midpoint formula, and this is where you might be wondering, should I be using co-vertices or should I be using vertices? The fact of the matter is that the center is located between both the vertices and the co-vertices. So this is up to you to pick whichever sets of points you want to use to find your center. I'm just going to stick to my vertices. So when I'm looking for my center, I'm just going to use the 2 values that were given for my vertices. So I can start plugging this into the equation. It's going to be x2 plus x1. So remember, it doesn't really matter which one you make x2 and which one you make x1. So it's going to be 6 plus -6 divided by 2, 0, 0 plus 0 divided by 2. And so this gives me the point 0, 0, because 6 plus -6 gives me 0, and 0 divided by any number is still 0, which gives me my point 0, 0. And then this also tells me that H is 0 and K is also 0. So I have all 4 variables that I need to start building my standard form equation for my ellipse, but there's one last question I have to ask myself. How do I know if A is going to be located under X or if A is going to be located under Y? A reminder, A tells us whether the ellipse is going to have a major axis that's horizontal or a major axis that's vertical. So what we need to pay attention to are the point values given. If I look at my vertices right here, my vertices are going to give me what A is. So if I look right here, the Y value is not changing. For both of them, Y equals 0. But here, the X value is changing. It started at -6 and it went to +6. This tells me that I'm moving along the X axis. So I know that A has to be paired with X. I can make the same observation here if I look at my co-vertices points. If I look at the X values, they're the same, 0, 0. They didn't go anywhere. But if I look at my Y values, this one started at 5 and then it went to -5. So I know my co-vertices are moving in the Y direction, which means that B will be paired with Y. So now the last thing to do is take all the information that we just found and write out our standard form equation. So I know that X goes with H, so X minus 0 squared divided by 6, because 6 is A, squared, plus Y minus 0, which is K, squared, divided by 5 squared is going to equal 1. So let's go ahead and clean this up. I can drop both the zeros because they don't do anything for us. So I'm going to have x squared over 36 plus y squared over 25 is equal to 1. So we were simply just given our vertices and our co-vertices, and using all the information we know about ellipses, we were able to come up with our equation. So here we're given, yet again, only 2 pieces of information, our vertices and our foci. We know half the distance between our vertices is going to give us A, and we know half the distance between our foci are going to give us C. We also know that if we either find the midpoint between the vertices or the foci, we can find the center of our ellipse. So we're going to have to use the same 2 set of equations from the last slide. So again, I want you to pause the video. I want you to find A, find C, and find your center for your ellipse. So you should check your work against mine. Hopefully I'm correct, but we have A is equal to 5, we have C is equal to 3, we have H equals 1, and we have K equals 4. Now, the problem is that we are missing B, and we need B in order to write our equation. So the important information here is that we know the relationship between A, B, and C. So I'm going to scoot this up just a tad bit. I know that C squared is equal to A squared minus B squared. So if I'm looking for B squared, I can rearrange this equation, and I can say that B squared is equal to A squared minus C squared. Or I could say B is equal to the square root of A squared minus C squared. So let me go ahead and solve for B. So this equals the square root of 5 squared minus 3 squared. So I have the square root of 25 minus 9, which is the square root of 16, which tells us that B equals 4. So now the last thing to do is figure out whether A goes under the X values or whether A goes under the Y. So if I look here again, my X value is the one that's changing and my Y value is the one that is staying the same. So we know that A is going to be paired with X. Okay, so let's go ahead and finish this problem by writing out our equation, I have x minus 1 squared plus y minus 4 squared. X is going to be divided by a squared, which is 5 squared, and y is going to be divided by b squared, which is 4 squared, and this all equals 1. Let's go ahead and finish this off by squaring our denominators. So I have x minus 1 squared plus y minus 4 squared. X will be divided by 25, y will be divided by 16, and this all equals. So we were able to write the standard form equation of an ellipse given only our vertices and foci. We know it has a center at 1 and 4. We know that half the distance between our vertices is 5, half the distance between our foci is 3, and half the distance between our covertices is 4. Okay, so the last way to solve for the standard form of an ellipse is algebraically when you're given an equation. And so this is going to look very familiar to what we did with circles. So I'm not going to list out all the steps, and I'm not going to give a thorough explanation on how to complete the square. If you need help with that, I would suggest you refer back to the circles video, or you reach out to me during office hours. So we always start by rearranging our terms alphabetically with the highest exponent. So I'm going to write this as 3x squared minus 42x plus y squared plus 4y is equal to negative 142. Remember, you always want to leave any number without a variable next to it out on the right-hand side of the equation. The next thing that I'm going to do is throw parentheses around my x terms and parentheses around my y terms. And I want to make my life easier, so I'm going to check to see if I can factor anything out. So I see that there's a 3 and a 42 in front of my x's. Those both share 3 in common, so I can factor a 3 out here. Over here, there is no common term between y squared and y, so I can't factor anything out. So when I factor out a 3, I'm left with x squared minus 14x. And then I'm just rewriting everything else. Y squared plus 4y is equal to negative 142. Now the next thing I want to do is complete the square. So this becomes x squared minus 14x. Remember, I need to add a c term, which is going to be b divided by 2a squared. So 14 divided by 2 is 7, and 7 squared is going to be 49, so plus 49. And now for y squared plus 4y, same thing. 4 divided by 2 squared is 4, so this becomes plus 4. And now whenever we add something to the left-hand side of the equation, we have to add it to the right-hand side. The one key here is since we factored out a 3, we have to do 3 times 49 when I add it to the right, and then also make sure to add the 4. So now I'm just going to clean everything up by factoring the left-hand side of the equation and adding everything together in the right-hand side of the equation. So I'm going to end up with 3 times x minus 7 squared plus y plus 2 squared is equal to 9. Now, the important thing about ellipses is that an ellipse equation in standard form is always equal to 1. So in order to make this equal 1, we have to divide our entire equation by 9. So let's go ahead and do that. Divided by 9, divided by 9, divided by 9. So when I simplify everything out here, we know that 3 and 9 share a common term of 3. So this is going to become x minus 7 squared over 3 plus y plus 2 squared over 9, and this is all going to equal 1. So here we have the standard form equation of an ellipse. There's a couple of things that we should be able to identify from the equation. We know that the center of the equation is located at 7, negative 2. And we also know that since A is located under the y term, this is going to be a vertical ellipse. We can also identify where our vertices, our co-vertices, and our foci are located, but I think this video is long enough. So if you go onto IXL, there's one activity over ellipses, and that is it for the week.